Welcome back to IAS Prep Corner. Today we dive into the axis and movements of the Earth. The rotation axis is an imaginary line that passes through the North and South poles. Earth spins around this axis from west to east, completing one full rotation every 24 hours. This spinning motion is what causes the regular cycle of day and night. Importantly, this axis is not perfectly vertical. It is tilted at an angle of 23.5 degrees from the vertical relative to Earth's orbit around the Sun. This tilt is crucial. Not only does it affect how sunlight reaches different parts of the planet throughout the day, but it also plays a key role in the formation of seasons when combined with Earth's revolution around the Sun. Orbital axis versus rotational axis. The orbital axis, also called the normal to Earth's orbital plane or ecliptic plane, is a conceptual reference line that is perpendicular to the plane of Earth's orbit around the Sun. It's not a physical object, but a geometric idea used in astronomy to understand Earth's orientation in space. Earth's rotational axis is the imaginary line that runs through the North and South poles, around which Earth rotates once every 24 hours. This rotational axis is tilted at an angle of 23.5 degrees relative to the orbital axis. This tilt is responsible for varying sunlight angles during the year and is a key factor in the creation of seasons. In summary, Earth's axis isn't straight up and down, it leans 23.5 degrees relative to the imaginary line perpendicular to its orbit. This tilt, combined with Earth's revolution around the Sun, leads to seasonal changes, varying lengths of day and night, and changing solar intensity at different latitudes. The North Pole. The North Pole is the northernmost point on Earth, situated at 90 degrees north latitude. It is the point where Earth's rotational axis emerges in the northern hemisphere. Due to Earth's 23.5 degrees axial tilt, the North Pole experiences extreme seasonal light patterns. Around the June solstice, the North Pole is tilted toward the Sun, resulting in continuous daylight, called the midnight sun, for about 6 months, from late March to late September. Around the December solstice, it is tilted away from the Sun, leading to continuous darkness, called polar night, for the other 6 months, from late September to late March. This phenomenon is unique to the polar regions and is directly caused by the tilt of Earth's axis as it orbits the Sun. Tropic of Cancer. The Tropic of Cancer is an important line of latitude located at 23.5 degrees north of the equator. It marks the northernmost point on Earth where the Sun can appear directly overhead at noon. This happens once a year during the June solstice, around June 21st, when the northern hemisphere is tilted toward the Sun. On this day, locations along the Tropic of Cancer receive the Sun's rays at a 90 degrees angle, resulting in the year's longest day in the northern hemisphere. The Tropic of Cancer's position directly corresponds to Earth's 23.5 degrees axial tilt, which is why the Sun's vertical rays never go farther north than this line. The orbital plane, also known as the ecliptic plane, is the imaginary flat surface that represents the path along which Earth orbits the Sun. It defines the geometric shape of Earth's orbit, which is slightly elliptical but nearly circular. Earth's axial tilt, approximately 23.5 degrees, is measured relative to this plane. Instead of standing straight up relative to its orbit, Earth's axis is tilted, which has major effects on sunlight distribution across the globe, the occurrence of seasons, the length of days and nights throughout the year. The tilt of Earth's axis in relation to the ecliptic plane is the fundamental reason we experience seasonal changes. Axis of the Earth and related concepts. Understanding Earth's motion and orientation in space is essential for grasping key geographical phenomena such as day and night, seasons, and the Earth's climatic zones. This understanding begins with a study of Earth's axes, planes, and specific latitudinal lines like the Tropic of Cancer. Rotation axis. The rotation axis is an imaginary line that passes through the North Pole and South Pole of the Earth. Earth rotates around this axis once every 24 hours, leading to the occurrence of day and night. This axis is tilted at an angle of 23.5 degrees with respect to a line perpendicular to the plane of Earth's orbit, orbital axis. This tilt is not only responsible for daily rotation but also plays a crucial role in the creation of seasons when combined with Earth's revolution around the Sun. Orbital axis. The orbital axis is a conceptual line that is perpendicular to the orbital plane, the flat, disc-shaped path that Earth follows as it revolves around the Sun. It serves as a reference for measuring the tilt of Earth's rotation axis. Earth's rotation axis is tilted 23.5 degrees away from this orbital axis. This angular difference between the rotation axis and orbital axis is the reason why the Sun's position in the sky appears to change throughout the year, causing seasonal variations. Orbital plane. The orbital plane, also known as the plane of the ecliptic, is the two-dimensional surface formed by Earth's orbit around the Sun. It can be visualized as a flat sheet in which Earth moves in an elliptical path. This plane is important in understanding how the Earth's tilt causes different hemispheres to receive varying amounts of sunlight during the year, thereby producing the seasons. Rotational plane. The rotational plane is the imaginary flat surface that is perpendicular to the Earth's rotation axis. If you imagine the Earth as a spinning disk or top, the rotational plane would represent the flat circular area created by the spinning motion. While not as commonly referenced as the orbital plane, the rotational plane helps in visualizing the Earth's rotation and the resulting centrifugal force that causes a bulge at the equator. North Pole. The North Pole is the point where the Earth's rotation axis intersects the surface in the northern hemisphere. Located at 90 degrees north latitude, it is the northernmost point on Earth. Due to the axial tilt, the North Pole experiences 6 months of continuous daylight, midnight sun, and 6 months of darkness, polar night, each year. This unique phenomenon highlights the significance of Earth's axial tilt in determining light distribution across the planet. Tropic of Cancer. The Tropic of Cancer is a major circle of latitude, located at approximately 23.5 degrees north of the equator. This line marks the northernmost point where the Sun can appear directly overhead at noon, which occurs on or around June 21, during the summer solstice in the northern hemisphere. The Tropic of Cancer is an important geographical marker that helps define the tropical zone, the region between the tropics of Cancer and Capricorn. Earth's axis and planes, an integrated understanding. Understanding Earth's orientation in space helps us decode many natural phenomena such as day and night, seasons, and climatic zones. The concepts of Earth's rotation axis, orbital and rotational planes, and key geographic markers like the Tropic of Cancer and North Pole are foundational in physical geography. Rotation axis, the cause of day and night. The rotation axis is the imaginary line through the north and south poles around which the Earth spins. This rotation takes approximately 24 hours, leading to the cyclical pattern of day and night. As different parts of the Earth face the Sun or move away from it, sunlight is received or lost, creating daylight and darkness. Orbital axis, the key to Earth's tilt. The orbital axis is a conceptual line perpendicular to the Earth's orbital plane. Earth's rotation axis is tilted by 23.5 degrees relative to this orbital axis. This tilt is essential, as it causes different parts of the Earth to receive varying amounts of solar energy during its annual revolution, giving rise to seasons. Orbital plane, the path of Earth's revolution. The orbital plane is the flat surface in which Earth revolves around the Sun in an elliptical orbit. It acts as a reference frame for measuring Earth's axial tilt and is a key factor in the seasonal changes experienced on Earth. When the northern hemisphere is tilted toward the Sun, it experiences summer, while the southern hemisphere has winter, and vice versa. Rotational plane, visualizing Earth's spin. The rotational plane is the imaginary flat disk that is perpendicular to the rotation axis. While it doesn't cause any direct phenomena, it helps in visualizing the direction and nature of Earth's spin. It is also useful in understanding centrifugal effects and Earth's equatorial bulge. Tropic of Cancer, a solar reference line. Located at 23.5 degrees north latitude, the Tropic of Cancer marks the northernmost point where the Sun can be directly overhead at noon. This occurs during the summer solstice, around June 21. It defines the boundary of the tropical zone and is a critical reference in understanding solar movement and climate zones. North Pole, the fixed point of Earth's spin. The North Pole is the northern tip of Earth's rotation axis. It experiences 6 months of continuous daylight and 6 months of darkness, a direct consequence of Earth's axial tilt. It also serves as a geographical reference for navigation and climate studies. Earth's rotation and its effects. The Earth rotates from west to east, completing one full rotation in approximately 24 hours. This rotation is responsible for the regular occurrence of day and night. As Earth spins, the side facing the Sun experiences daylight while the opposite side experiences night. This rotation not only governs time but also significantly influences natural phenomena such as twilight, wind patterns, and ocean currents. In comparison, other planets exhibit interesting variations in rotation. For example, Venus rotates extremely slowly and in the opposite direction, retrograde rotation, taking about 243 Earth days to complete one spin. On the other hand, Uranus rotates on its side, with an axial tilt of about 98 degrees, making its rotation appear almost horizontal. These differences affect planetary climates and solar exposure patterns. On Earth, the rotation causes the Coriolis effect, which deflects moving air and water, shaping global wind systems like trade winds and ocean currents such as the Gulf Stream. Additionally, rotation is responsible for the presence of twilight, the period between daylight and darkness, by allowing gradual changes in sunlight angle. Thus, Earth's rotation is a fundamental driver of many dynamic systems, both environmental and astronomical, making it a critical concept in physical geography and planetary science. Earth's revolution and the origin of seasons. The Earth revolves around the Sun in an elliptical orbit, taking approximately 365.25 days to complete one full revolution. This motion, combined with the tilt of Earth's rotation axis, 23.5 degrees, leads to the formation of seasons. As Earth moves around the Sun, different parts of the planet receive varying intensities and durations of sunlight, giving rise to seasonal changes. Two important astronomical events during this revolution are the equinoxes and solstices. The equinoxes occur around March 21 and September 23, when the Sun is directly above the equator. On these days, day and night are approximately equal in duration all over the world. The solstices occur around June 21 and December 21. On June 21, the northern hemisphere is tilted toward the Sun, resulting in the longest day and shortest night. This is the summer solstice in the northern hemisphere. Conversely, on December 21, the southern hemisphere is tilted toward the Sun, making it the winter solstice in the northern hemisphere with the shortest day and longest night. Thus, the interplay between Earth's axial tilt and its annual revolution around the Sun is the primary cause of seasonal variation, which in turn influences agriculture, climate, and daily life, key concepts for both the geography and environment sections of the UPSC syllabus.